Hello. Today we're talking about solving systems with three variables. Now the idea behind solving systems with three variables is the same as solving systems with two variables. We're just adding another letter, and it adds just more to do. You'll notice that the equations here not only have an x and a y, but also have a z component to it. Oftentimes this is used in graphing in 3 dimensions. But what we're going to do today is we're going to solve these to find one point, an x, a y, and a z, by using elimination. So elimination works, and I color-coded these equations just so we know to help you with the roadmap as what are you doing when. So the first thing you want to look at is you want to pick two of these. Okay, I'm going to pick the top two. And I'm going to try and eliminate one letter from here. Now, it doesn't matter what letter you want to eliminate from, as long as you pick one. So I'm looking at this, I'm thinking nothing really eliminates easily, so how about we pick y to eliminate? And if I do that, I'm going to have to multiply the bottom equation times a 3. If I multiply that, everything in there times a 3, and then that bottom equation, I'll have a plus 3y, and I'll have a minus 3y. The y will eliminate, and I'll be able to do it. So let's do that. So first, I'm going to start with just copying that top equation down. 2x plus 3y minus 4z equals 20. Then, as I multiply everything times 3, I'll have a 12x minus 3y plus 3 times 5 is 15z equals, and don't forget that 3 times 13 is 39. From here, notice my y's. My y's will eliminate. That's good. So let's go old school addition problem. Here we go. 2x's plus 12x's is 14x's. My 3y and minus 3y cancels out. Minus 4z plus 15z is going to be a plus 11z equals 20 plus 39 is going to be a 59. So now notice what it leaves me is it leaves me another equation. It has two variables. Now I can't eliminate anything from that, so until I get another two-variable equation. So to find that, I'm going to pick two others. Now, I haven't used this blue equation yet, so let's use that blue equation. And I think let's use the green one as well. That looks the easiest to make. So if I eliminate those two equations, I'll need to multiply. Now, here's another thing. You have to eliminate the same variable you did last time. So I eliminated the y last time, so I need to eliminate the y again. I need to multiply my green equation times a 2 to get that y to eliminate. So let's start it again. So multiplying everything times 2, I'll have an 8x minus 2y plus 10z equals 26. And then that should eliminate now with my blue equation, which is 3x plus 2y plus 4z equals 15. Now we can eliminate. So add these together. We have a 8x plus 3x is 11x. We have a minus 2y plus 2y. That will eliminate. And a 10z and a 4z is a plus 14z equals 26 plus 15 is 41. Now I have two equations, and now I can eliminate these two together. So my first equation is this 14x plus 11z equals 59. And let's see, what do I have to multiply both of these two by? Now, it doesn't matter which you need to solve by. Do I want to eliminate the x? Do I want to eliminate the z? That's not going to matter so much. So whichever looking at these numbers works. Well, we kind of have the same. It's kind of both 11 and 14. So we're going to have to, let's get rid of our z. So let's multiply the first equation here by a 14. And let's multiply the second equation here by an 11. Okay, so the first equation is going to look like 14 times 14 is going to be 196x. Big numbers, I know. 14 times an 11 is going to be a plus 154z equals, and 14 times 59 is going to equal 826. Actually, let's multiply this times a negative 11 so that we have negative signs on the bottom. So negative 11 times negative 11 is negative 121x minus 154z. That's good because now our z's will cancel out and eliminate. And 41 times 11 is 451. Now I can eliminate these two guys. So eliminating these, we'll have, let's see, 75x. My z's will eliminate, and we will have, let's see, borrow from the 12, minus 5 is 7, 375. So now I have an equation of 75x equals 375. So let's divide by 75. Divide by 75. And x will equal 5. Once we're here, now that we have x equals 5, we're home free. And just like in solving substitutions with eliminating, once we got one variable, we'd take one and put it back into the original. And that's what we're going to do too. It doesn't have to be an original. We can use any formula along the way. And so to find my second equation, I'm going to pick one that has an x and only one other letter. So that would be a z. So let's find the z next. Which one, it honestly doesn't matter. I'm going to use this equation over here. So I'm going to write 11 times x we said was 5 plus 14z equals 41. Now let's solve that equation. 11 times 5 is 55 plus 14z equals 41 minus 55 to both sides. 14z will equal a negative 14. So divide by 14 on both sides, divide by 14 on both sides. Z will equal negative 1. So now we have x. Now we know z. We can now solve that and find a y. So let's go to one of our original equations, which looks the easiest. I'm going to pick the green one just because that green one only has a single y to solve for. So we're going to write 4 times, we said x was 5, minus y plus 5 times, we know our z is a negative 1, equals 13. Now let's solve. So 4 times 5 is 20 minus y plus, well, that will be a negative 5 equals 13. So 20 minus 5 is 15 minus y equals 13. Minus 15 to both sides, minus 15 to both sides. We'll have a minus y will equal a minus 2, so a positive y divided by negative 1 on both sides gives us a positive 2. How I want to write this as my final answer will be in a form of a coordinate point. And in 3 dimensions, we actually have coordinates that have 3 numbers. So the x was 5, the y was 2, and z was minus 1. So this is my final answer, 5, 2, negative 1. Now, if along the way you run into a problem where both variables drop out, if you have something like you get to your 2 steps and you have 5x plus 3z equals 10 and a minus 5x minus 3z equals minus 10, if they're the exact same and you have 0 x's drop out, the z's drop out, and it equals our number, and that drops out, and all the letters are gone, then you're going to run into, this is going to be a line where the 3 planes cross. This is infinitely many solutions. If, on the other hand, you had, say, something like 5x plus 3z equals 10, and minus 5x minus 3z equals minus 9, and you eliminate, and you get x drops out, z drops out, and it equals 1, so 0 plus 0 is 0. 0 equals 1. Well, that's not true. That's definitely not equal to each other. Then instead of infinitely many solutions, your answer will be a no solution. So just like solving equations when you had 2 variables, the same rules apply with infinitely many solutions and no solutions. I know it's a lot of work, but good luck. And just be very consistent. Don't mix up any negative signs. Take your time through it. You'll be glad you did. Have a great day.